on the current batch.
Reading steady at 14%.
The journey of flour begins in vast agricultural fields where wheat is grown, harvested, and prepared for transport. Farmers cultivate different varieties of wheat depending on climate and intended use. Some are high in protein, ideal for bread. Others are softer, suited for pastries and cakes. Once mature, the wheat is harvested using large combine harvesters that cut, thresh, and clean the grain in a single continuous operation. After harvesting, the wheat is transported, often in bulk, by trucks, trains, or ships to milling facilities. When it arrives at the factory, it is not immediately processed. Instead, it undergoes careful inspection before being accepted into the system. At this stage, quality begins to matter. Before unloading, samples of wheat are taken for testing. Technicians analyze moisture content, protein levels, grain hardness, and contamination. This ensures that the wheat meets industry standards and is suitable for processing. Any batch that does not meet these criteria may be rejected or redirected for alternative uses. Approved wheat is then unloaded into large intake pits, where it begins its transition from raw agricultural product to industrial material. From here, it moves into storage. Wheat is stored in massive vertical silos, designed to hold thousands of tons of grain. These silos are not just storage containers. They are part of a controlled system that maintains grain quality. Temperature and humidity are carefully monitored to prevent spoilage, mold growth, or insect infestation. In many facilities, different types of wheat are stored separately to allow for blending later in the process. This blending is crucial. It allows millers to create consistent flour, even when raw materials vary slightly from batch to batch. Once the wheat is ready, it is released from the silos and sent into the cleaning system. Before grinding begins, the wheat must be thoroughly cleaned. Even after harvesting, wheat can contain impurities such as dust, stones, straw, metal fragments, and other foreign materials. The cleaning process is multi-stage and highly systematic. First, the wheat passes through vibrating screens that separate large debris based on size. Then, air currents remove lighter particles like dust and chaff. Magnetic separators extract any metal contaminants, protecting downstream machinery from damage. In some cases, gravity separators are used to remove stones and other dense impurities. This stage ensures that only clean, safe grain enters the milling process. But even now, the wheat is not ready to be ground. It must first be conditioned. Conditioning is a critical step that prepares wheat for efficient grinding. Water is carefully added to the grain to adjust its moisture content. This process softens the bran, the outer layer of the wheat kernel, while keeping the inner endosperm firm. The conditioned wheat is then allowed to rest for several hours, or even longer, depending on the type of wheat. During this time, moisture distributes evenly throughout each grain. This step is essential because it makes it easier to separate the bran from the endosperm during milling. Without proper conditioning, the grinding process would be less efficient and produce lower quality flour. Once conditioning is complete, the wheat moves into the heart of the factory, the milling system. The first stage of grinding is known as the brake system. Here, the wheat passes through a series of large steel rollers that rotate at different speeds. Instead of crushing the grain all at once, these rollers gradually open it up. Each pass through the rollers breaks the wheat into smaller pieces, separating the bran from the endosperm. After each grinding step, the material is sifted to separate coarse particles from finer ones. The coarser material is sent back through additional rollers for further breakdown. This process is repeated multiple times, ensuring that the grain is progressively reduced without damaging its internal structure. The goal is not just to grind, but to separate. Between each grinding stage, the material passes through sifters, large machines fitted with multiple layers of fine mesh screens. These sifters sort particles based on size. Fine particles, which are closer to flour, pass through the screens and move forward in the process. Larger particles are redirected for further grinding. At the same time, air classification systems help separate lighter bran particles from heavier endosperm fragments. This combination of mechanical and air-based separation ensures a high level of precision. At this stage, the process becomes a continuous cycle of grinding, sifting, and sorting. Each pass refines the material further. After the initial break stages, the material enters the reduction system. Here, smoother rollers are used to grind the purified endosperm into fine flour. Unlike the earlier stages, this phase focuses on achieving a uniform texture. The rollers operate with extremely small gaps, producing flour particles of consistent size. This stage is where the transformation becomes visible. What began as whole grains is now turning into a soft, powdery substance. However, not all flour is the same. Different streams of flour are produced throughout the process, each with slightly different properties. These streams must be carefully managed and blended. Modern flour mills produce multiple streams of flour during milling. Each stream may vary in protein content, color, and texture. To create a final product that meets specific standards, these streams are blended together in controlled proportions. This blending process ensures that the flour is consistent regardless of variations in the raw wheat. In many factories, automated systems monitor and adjust blending in real time. This level of control is essential for meeting the requirements of different applications, from bread baking to pastry production. Once blended, the flour is almost ready for use. But first, it must be refined and stabilized. In many regions, flour is enriched with vitamins and minerals. This step helps improve nutritional value, especially in populations where flour is a dietary staple. Common additions may include iron and certain B vitamins. These nutrients are carefully measured and mixed into the flour using precision dosing systems. The goal is to ensure even distribution throughout the product. In some cases, small amounts of additives may also be used to improve baking performance or shelf life. However, these additions are strictly regulated and vary depending on local standards. Before packaging, the flour undergoes final sifting to remove any remaining coarse particles. This ensures a smooth, uniform texture. At the same time, quality control tests are conducted. Samples are analyzed for moisture content, particle size, color, and baking performance. In many facilities, laboratory technicians perform test baking to evaluate how the flour behaves in real-world conditions. This step ensures that the product meets both industrial specifications and consumer expectations. Only after passing these checks is the flour approved for packaging. The finished flour is transported through enclosed systems to packaging lines. Here, it is automatically weighed and filled into bags of various sizes. Small retail packages are prepared for consumers, while large sacks are produced for bakeries and industrial users. The packaging process is highly automated. Machines fill, seal, label, and stack bags at high speed. Dust control systems ensure cleanliness and prevent product loss. Each package is marked with batch information, allowing traceability throughout the supply chain. From here, the flour is ready for distribution. Flour is transported in multiple ways depending on its destination. Large quantities may be shipped in bulk containers or tanker trucks. Smaller packages are distributed through warehouses to supermarkets and retailers. Efficiency is key. Flour mills operate continuously, supplying a constant flow of product to meet global demand. From local bakeries to international food manufacturers, the reach of flour extends across every level of the food industry. If you enjoyed this deep dive into industrial food production, consider exploring more factory processes that shape the products we use every day.